Hi everyone. Thank you for sticking around for the very last presentation. I'll try to be quick so that we can go out and enjoy the beautiful weather here. My name is Zhou. I am an assistant professor at UBC, and the paper I'm going to present today is titled Bias in Generative AI. This is joint work with Abhishek from UC Irvine and Kanam from Carnegie Mellon University. So in today's conference, we have already discussed extensively about the impact of generative AI on business. And it is predicted that generative AI can add trillions of dollars to the global economy. And its ability to create many different types of content, from text to code to image and even to videos, can potentially outpace human production capacity by the year of 2030. And this is the prediction given by JP Morgan. And particularly in the area of marketing, generative AI has the capacity to revolutionize the generation of creative content, such as advertisements. So for example, on the right-hand side, this is a news article which was published in May, earlier this summer, and this was announcing the partnership between the world's largest advertising agency and NVIDIA to create advertisements using this new technology, using generative AI technologies. So this is exciting, but also scary, because these technologies, they are not perfect. There are critical concerns about generative AI. For example, potential propagation of bias. So this is something we focus on in this paper. Given that marketing is dominant in affecting individuals' perceptions, we believe that generative AI can have a significant impact on shaping our society. And other issues such as intellectual property rights. And this is because a lot of these models, they were trained on a lot of data, tons of data, without asking for permission of the original content creators. So this is also another critical issue that caused a lot of debate in the law community. And the accuracy of the output, as well as explainability of the results, these are all critical concerns of this technology that should be addressed as these models have been increasingly adopted in many different domains, such as marketing and education. So in this paper, we focus on investigating potential bias of three popular text-to-image models. So this is our setting. We focus on three of the most popular image generators. The first one is Midjourney. Midjourney has become very popular for producing high-quality photos. And Midjourney has attracted more than 15 million users, and their business model is based on subscription. So users can pay from $10 a month to $120 per month to use their services. On the right-hand side, this is a news article about a picture created by Midjourney that has recently won an award prize in Colorado. And as you can imagine, some artists are not happy about this. And this caused a lot of debate in the art community. And so this is the photo that has won this award, created by Midjourney. And the second model we investigate is DALL-E 2, which is the latest version of DALL-E, introduced by OpenAI. And this one is also very easy to use. The users can type in some text, and then DALL-E will automatically generate the picture. So the cost is different for DALL-E. This one is based on pay by usage. The cost is about 2 cents per picture. The higher the resolution, the higher the price. The last one here is free. So Stable Diffusion is open source. The first two are both closed systems. The users have no idea what is going on in those models, and Stable Diffusion is free. And you can download the model and run it on your own laptop. So it is reported that Stable Diffusion has also attracted at least 10 million users. So there is a very large community out there using Stable Diffusion for various purposes. So to investigate potential bias in these models, we first construct our image data using all of the three models. So we structured our prompt as a portrait of X, with X in different occupations, such as bakers, dancers, auditors, actors, so on and so forth. So we use a very simple prompt. And then to obtain a full list of occupations, we resort to the ONET database, which is a very comprehensive and probably the most widely used occupation database that is regularly updated by the US government. So in this ONET database, there are 1,016 occupations, and then we use all of the three models to generate various portraits of occupations. So in Midjourney, every time we provide a prompt, Midjourney will automatically return 4 different images. And for DALL-E and Stable Diffusion, each prompt will generate 1 unique image. So we repeat this generation process, and for these 2 models, we have 2 different images for the same prompt. And in total, about 8,000 images were generated using all of the 3 models, and we use consistent prompts. And so here I'm going to show you some examples in our data, and these are examples created by Midjourney. So on the left-hand side, we have a portrait of personal financial advisors. And as you can see, these photos are reasonably high quality. And the only thing I need to do to create this photo using Midjourney is to provide this 1 line of description. So a portrait of personal financial advisors. And then on the right-hand side, we have a portrait of executives. So here are more examples. We have a portrait of chefs and head cooks. On the right-hand side, we have a portrait of food preparation workers. And here we have a portrait of anesthesiologist assistants. On the right-hand side, we have a portrait of dishwashers. And the reason we use this kind of structured prompt is that if we directly put, say, dishwashers into the model, then this will return a dishwasher machine instead of dishwasher workers. And here are 2 more examples. We have a portrait of economies, and then we have a portrait of brokerage hubs. So as you look at these photos, you probably guessed where I'm going here. So for each image in our data, we first analyze the faces. So we use Face++ to detect a bunch of attributes, such as gender, age, emotions, etc. And for example, here, this is a portrait of bakers, and we detected that there is 1 male versus 1 female. So we calculate the gender distribution in this photo as 50% male versus 50% female. And then we aggregate the results across the entire data set. And here's the result for each of the 3 models. And so the first one here, this is Midjourney on the left, and Stable Diffusion, and DALL-E 2. And this is the gender distribution in all of the 3 models. So the blue bars here are representing males. The pink bars with slashes, these are females. And then the dashed line, this gray line here, this is representing 50% statistical parity. And as we can see, all of the 3 models, they are biased against women. And the magnitude of bias is also quite large. For example, for Midjourney, the distribution is about 80% male versus 20% female. And then for Stable Diffusion, this is about 70% male versus 30% female. And for DALL-E, this is 60% male versus 40% female. So this is looking at the gender distribution at the aggregate level. And then we further divide these occupations into different job zones. So in the ONET database, there is a descriptor of job zone, and this is a table that we borrow from another paper presented in this conference, GPTs are GPTs, and these occupations are classified into different job zones based on the required level of preparation. So for example, in job zone 1, this requires minimum preparation, which is usually from 0 to 3 months. And the median income level for these job zone 1 occupations is also the lowest, which is around $30,000. And then job zone 5 requires the most extensive preparation, which is usually more than 4 years. And the income is the highest for these type of jobs. So again, we aggregate the results for each of the 3 models. And here, for within each figure, we have job zone 1, 2, 3, 4, 5. As you can see, the gender distribution existed in all of the job zones, except for the last job zone 5 in the DALL-E model. And we also see that the degree of bias is slightly reducing as the job load increases. And here's another way to classify these occupations. We use the bright outlook descriptor, which is also provided in the ONAT database. And bright outlook occupations are those that are expected to increase rapidly in the next several years. We'll have a lot of job openings for our new and emerging occupations. In this ONAT database, there are about 340 occupations that are classified as bright outlook. And again, we see the gender bias in both types of occupations, with the degree of bias being relatively smaller in bright outlook occupations. And this is another descriptor we use to classify the jobs, the STEM occupations, which are occupations that are listed that require education in science, technology, engineering, and mathematics. And there are about 300 occupations, STEM occupations in the database. Again, we see gender bias in both types of occupations. And the next thing we did is to classify the races in each of those images. So we categorize the race of each face detected in our data as either white, black, Asian, Latino, Indian, or Middle Eastern using the deep face framework. And this is again the distribution at the aggregate level for all of the three models. Okay, so we have Midjourney on the left, Stable Diffusion in the middle, and DALL-E on the right-hand side. And as we can see from this figure, all of the three AI generators, they are biased against black individuals. Okay, so this black bar here, this is representing black individuals, the percentage black individuals in those pictures. And for Midjourney and DALL-E, we have consistently found that the percentage of white individuals is greater than 50% in each of the 5 job zones. And for Stable Diffusion here, we see a relatively high representation of Asians, this green bar. And this is potentially because we used a pre-trained Stable Diffusion model, which is called realistic vision. And this is one of the most widely used Stable Diffusion model that is for the purpose of generating realistic images. So that version of Stable Diffusion was trained on a data set that have a lot of Asian representation. So some of you might be wondering, these biases that we found in these models are simply reflecting the disparities in the real world, right? We don't have many female CEOs, for example. In order to test this hypothesis, we use 2 different benchmarks. The first benchmark we use is from labor force statistics. So this is by the US government. And we also collect some data from Google image search, because these models, they were trained on data collected from internet. So we are not saying these 2 benchmarks are perfect. They have their own problems. Here we are simply comparing the biases in these models with those embedded in the labor force statistics and Google. And on the left-hand side here, we have the female distribution for Midjourney, Stable Diffusion, DALL-E, and the 4th one here is ELS. The last one here is Google. First of all, for the representation of female, we do not see significant difference between Google and labor force statistics. So the image we collect from Google, by the way, when we collect the image data from Google, we use the Google API. We use the prompts as the search keywords. So we basically search for, say, a portrait of bakers, and then we say the first 10 results for each of the prompts as the keyword. But then when we compare the female representation in those 3 models with these 2 benchmarks, we found that these, all of the 3 generative AI models, they exhibited amplified gender biases beyond the status quo. Okay, so the biases contained in those models are even worse than the status quo. And this is also true for the representation of Black individuals. And so on the right-hand side, we have the box plots for the 5 data sets. And again, we found that all of the 3 AI generators and also Google, the representation of Black individuals is significantly lower than that in the VLS, labor force statistics. Okay, so basically all of the 3 AI generative models, they amplify the real world disparities. And now we further look at some facial expressions. It's not only important to look at who is showing the pictures, but also in what light they are showing those photos. So we detect some facial attributes such as age, smile, emotions, etc. And this is the result for age and smile. Okay, so on the left-hand side, we are comparing the average age between different genders in each of the 3 models. And again, we see that for all of the 3 models, male appear to be older consistently than female. For example, the average age of male in Midjourney is around 48, whereas from female it's about 32, 35. And then on the right-hand side, we have the comparison for detected smiles in their faces. And then we found that female consistently appears to be more smiling in those pictures than men. And this stereotype is also consistent in all of the 3 models, ranging from commercial to open source. And here, this is the result for emotions. So the emotions of the faces, there are different categories: anger, disgust, fear, happiness, neutral, sadness, surprise. And again, we found consistent stereotypes. For women, they express more happiness than men across all of the 3 generators. On the other hand, men appear to be more neutral, and they show more anger than women across all of the 3 AI generators. So this is also troubling because this may inadvertently portray men in a position of more authoritative than women who appear to be more smiling and happy. So to quickly wrap up this talk, we focused on 3 most popular image generators, and we have found the presence of various biases and stereotypes embedded within these popular AI systems. And the degree of bias in these systems is also a matter of significant concern, which should be addressed, especially when they are rapidly adopted in many different domains. And I'd be happy to take any questions. Thank you.